Okay, so today we're looking at the gradient. Again, a concept you should have done before. The gradient measures the slope of a line. So what we're looking at is how far the line goes up or down every time we go across. So we measure it as rise over run, which is just the basic concept that you need to remember. And we're now going to look at how the formula for the gradient was derived. So if you are looking at the interval AB, so this line will continue on forever, but we have 2 points on the line, A, which is x1, y1, and B, which is x2, y2. And we want to know what is the gradient for this line, what is the gradient of the interval between A and B, something like that. So when we're talking about rise, we're talking about vertical rise. So we need the line that comes straight down from B. Then when we talk about the run, we are talking about horizontal run, so straight across from A. So this here is your rise, and over here is your run. Now, we talked before in one of the previous videos about how to find these distances. We know that the length of this vertical side here is y2 minus y1, and we know that this length here, the run, is x2 minus x1. So what that means is that we then have a measure for the gradient. So we know that it's rise over run. The rise is y2 minus y1. The run is x2 minus x1. And that's how you get the formula for the gradient. So some of the things that we know about gradients are positive gradient goes up like that. A negative gradient heads down like that. And a zero gradient is flat. Question for you to answer in class. What is a vertical gradient? I'll be checking on that when you come back in. So something to think about, and this will mean more later when we get into differentiation, but a gradient is a measure of the rate of change of y with respect to x. So what that means is every time I go across 1 for x, what we're finding is how much y changes. So the rate that it changes. Does it go up by 1? Does it go up by 3? Does it go up by 5.5? Does it go down by 2? Does it go down by 7? Every time x goes up by 1. So we're measuring the rate of change, the rate that it is increasing or decreasing as we increase x. So here are some examples. We want to find the gradient of a line that passes through the points 5, 7 and 2, 5. So just as before, you're going to decide on your x1, y1 and x2, y2. And again, it doesn't matter which one's which, because as long as you stick to the same one, so 5 and 7 are both number 1, not one of them being 1 and one of them being 2, because then everything will go wrong. Start with your formula, substitute in. So y2 minus y1 means that we have 5 minus 7. And x2 minus x1 means we have 2 minus 5. The beautiful thing about this formula is it works out whether it's a positive or negative gradient without you ever even looking at the graph, because that's something that kids sometimes mix up. They get so focused on working out what the rise and the run are from a picture that they don't stop to consider about whether the graph is increasing or decreasing. The formula takes care of that for you. Always something to consider if you're working graphically. So 5 minus 7 is negative 2. 2 minus 5 is negative 3. Negative divided by a negative is a positive. So the gradient of the line that passes through the points 5, 7 and 2, 5 is 2/3. Now we're going to work with some negatives in the next one. This is the one place you've got to be just a little bit careful, because it's very easy to make a simple mistake when you substitute in and miss out on a negative. Write down 1 when there should be 2 or something like that. So we've got the points 1, 6 and 3, negative 7. So what I'm going to do is x1, y1, x2, y2, just like before. Start off with your formula and then substitute in. So y2 minus y1, so minus 7 minus 6, all over x2 minus x1, 3 minus negative 1. And there's your trick, because sometimes people will leave out that negative. They will put in the minus and then they'll forget that it's negative 1 and that they're going to cancel each other out. Okay, so minus 7 minus 6, we get negative 13, and 3 minus negative 1, so we get 4. So the gradient passing through those 2 points is negative 13 over 4. Now you can turn that into a mixed numeral if you want to, but there's no advantage in it, so generally I would leave it as an improper fraction. So now I want you to consider this. When we're looking at this line, we know that the gradient is rise over run. That's your definition of gradient. But this line also makes an angle when it crosses the x-axis, and any line other than a horizontal line is going to make an angle with the x-axis. So I want to consider what that means in another way. So just as before, we look at this and we make our triangle. Now I know that this side here is the rise, and I know that the side down here is the run. But instead of considering it in a linear function way, I want you to think about it trigonometrically. Rise over run. If we call the angle that it's making with the x-axis theta, then what I have here on the side that says rise is the opposite side to theta, and run is the adjacent side to theta. Well, which trigonometric ratio uses the opposite and the adjacent? That would be tan. So the gradient is also equal to tan theta. Now that can tell us some other information. For instance, what angle the line makes when it meets the x-axis. Okay, so hopefully when you see the example this will make a little bit more sense. What we want to do is find the gradient of a line that makes an angle of 30 degrees with the x-axis in the positive direction. So what they're telling us is that this angle here is 30 degrees. And we want to know, well, what is the gradient? So think back, 30 degrees in a triangle, what does that tell us? Well, for that we use our exact ratios. So we're talking 30 degrees, which means that the angle at the bottom here is 60 because there's our right angle. If that's our right angle, this side here is 2. The side opposite 30 degrees is 1, and the opposite of 60 is root 3. So looking at that, we know that the gradient is equal to tan theta. That's what that thing that we did above says. Well, what is tan theta? Tan of 30, sorry. Looking at our triangle, if we're talking about tan of 30, because that's what our gradient is, they've told us that it's equal to 30 degrees. Tan of 30 is equal to 1 over root 3. So the gradient for this line is 1 over root 3. So exercise 7.3, below are the questions I want you to do. You need to do more than that, you are welcome to, but as a minimum you must do 1, 4, 6, 9, 13, 15, 16 and 19. Good luck, and I'll see you in class.